will be made by Professor Oleksandr Bochechka, Diamond-tungsten carbide nanocomposite, and smoking element for fine tuning.
Ladies and gentlemen, regulators, I have the honor to present here the Diamond Institute for Super Hard Materials of the National Academy of Science of Ukraine.
Стрілка право, направо, направо. Стрілка.
The object of our study is of unexpected diamond patterns. We have used two types of patterns. The first, that is an action synthesized diamond nanopatterns, so named ultra-dispersed diamond. The standard material for synthesis is exposing itself. The second, there is statically synthesized diamond. Generally, graphite is the starting material for diamond synthesis in this case. The aim of this work is to obtain diamond-tungsten composite from diamond nanopowders for using as working element of fine-tuning instrument.
Зараз буде зараз.
As you know, the decreasing grain size is the main method to activate sintering in powder metallurgy. But if we sinter the diamond powders, we attain another result. As the grain size decreases, the density and physical-mechanical characteristic decrease too. In our opinion, there are at least two reasons for this. The first, the difference in direction between external forces acting on the system and internal capillary forces. The second, the interaction of diamond particles with oxygen and oxygen-containing groups on their surface. In the case that the pore forces are opposite, the compaction degree decreases, but amine pressure on the pore surface increases. According to our calculations, for diamond powders with particles of size 200 nanometer and below, the temperature and pressure in diamond volume during sintering correspond to the diamond thermodynamic stability ratio. This excludes the diamond graphitization by a direct transformation of diamond to graphite. The graphitization occurs owing to the interaction of diamond particles with oxygen and oxygen-containing groups. So, if you want to and then realize vacuum degassing of the organic compounds. For high pressure sintering, we should usually use a toroid high pressure apparatus. The working pressure in this apparatus is about 8 gigapascal. Our experiments have shown that vacuum degassing practically stops the graphitization process during the turn of statically synthesized diamond nanoparticle. This doubles the hardness. For the reaction synthesized diamond nanoparticle, degassing also significantly improves the sintering. But in high temperature reaction, the density decreases with increasing temperature. To improve the sintering, it is necessary, in parallel with degassing of diamond nanoparticles, to choose additives which both form chemical compounds with carbon and thus bond diamond nanoparticles in sintering. Of the metals which form refractory cabinets, only tungsten used as an additive improves the sintering of diamond nanoparticles. Compounds sampled were sintering from the mixture of diamond and tungsten trioxide nanoparticles. The mixture was prepared in a liquid medium. It was treated in a hydrogen atmosphere. You can see the result of high pressure sintering in this mixture. According to X-ray analysis, the sinter samples include tungsten carbide and trioxide tungsten carbide. Tungsten carbide was formed as a result of both the direct interaction of diamond with tungsten and reaction in the tungsten carbon oxygen system. Nanoparticles of tungsten carbide have formed in void between the diamond nanoparticles. They are chemically bonded with diamond. The composite has the structure in which the tungsten carbide and diamond grains are regularly placed and are uniform in size. With optimal sintering parameter and composition, the resultant composite shows high hardness, fracture toughness, and thermal stability. We conducted a study of the process fine-tuning of aluminum alloy by instrument with a circular cutting insert made of this material. It was found the influence of technological processing conditions on the cutting force components, the magnitude of vibration, roundness, and painless of the machined surface. Based on the obtained data, the processing regimes have been selected. Under the conditions, the treatment of aluminum alloy A6 by cutter made of nanocomposite diamond tungsten carbide provides roundness about 400 nanometer and values about 700 nanometers. You can see conclusions which I have recorded. The other science professor Mr. Zinterev dioxide on mechanical characteristics. If we have more tungsten dioxide, we have not high level of mechanical characteristics. The tungsten dioxide decreases the level of hardness, fracture toughness, and other characteristics. Because the tungsten dioxide is very quickly cracking.
Maybe more questions?